Variables x and y are connected by the relationship y equals ax to the n, where a and n are constants. Transform that relationship into straight line form. Well, let's take logs of both sides. I'm just looking down at the rest of the question. I'm going to take natural logs. So ln y would be equal to ln ax to the n. Now we have the log law, of course, that log a plus log b is log ab, which I'm going to use in that direction to write log a plus ln x to the n. And then, of course, we've got the log of a to the n is equal to n log a, which we can use just here for ln y to be equal to ln a plus n ln x. And that's now in straight line form. It's of the form y equals c plus mx, where the y is ln y and the x is ln x. Values of ln x and ln y were plotted and a straight line graph passing through 0, 0.5 and 3.2, 1.7 was obtained. Now it's important to note that this would be a value of ln x and this would be a value of ln y. So, and the same being true of this point here, we can say that 0.5 is equal to ln a, and of course ln x is 0, so that bit would disappear. And that gives me that a is equal to e to the 0.5. We'll worry about that in a moment. And then using this other point here, we have that 1.7 is equal to ln a plus 3.2 n. So we can give an approximate value for this. So we've got e to the 0.5 is 1.65, correct, 2dp. And then over here we've got 3.2n is going to be, so that will be 1.7, take away 0.5 because ln a is 0.5, and so n is going to be 1.2 divided by 3.2, which is 0.375. So finally we want to find the value of y when x is 11. Well, we now know that y is equal to e to the 0.5 x to the 0.375. So y is going to be e to the 0.5 multiplied by 11 to the 0.375. So that's e to the 0.5 multiplied by 11 to the power 0.375, giving us 4.05, correct to 2 decimal places.